Hello, welcome back to my channel. Good morning, good afternoon, good evening. Alright, so in this tutorial we are going to be handling how to size a storage tank. Okay, so this is a storage tank. We are using this tank to store this particular stream, and this stream has a mass flow rate of 5,000 kilogram per hour, and the compositions or the components we have methane and we have a hypothetical component. Alright, so also if you check the phase fraction, we have about 83.36% of vapor and approximately 17% of liquid. So if you check over here, we'll have more of the vapor coming out here. So out of the 5,000, we have about about 2,421 kilogram coming up. Then we have approximately 2,579 coming down. Alright, so now this is our storage tank. So what we want to do now is I want to size this storage tank. So all we need to do is come over to equipment design. Alright, so click on add, then we'll select vessel sizing. Under vessel sizing you see separator, select separator, we select V100, that's the name of our storage tank. So click OK. Excuse me. Click OK. As you can see, it's size. So go to sizing. If you go to sizing, you see the active specification, so you can select any of these as the active specification, then put the value. Okay, but this is the active specification. So the liquid residence time is about 300 seconds. Then the start top is about 0.3048. So let's look at the performance. Now if you look at the performance, the sizing results, you see that the diameter of this particular storage tank will be 1.067 meter. The total length, which is the height, is about 3.734 meters. Now also the geometry or the orientation of the storage tank, you have to select. If you want it to be horizontal, you can select this. Okay, if you want it to be vertical, you can actually select. So let's look at the output values for horizontal for this particular storage tank in the horizontal orientation. So you come over to this place. As you can see, the diameter is 0.6096, the total length is 1.829. You notice that something really changed, right? Fine. So you also check the vapor space. You see vapor space height with 0.3691. Now, but if you come back and change it to vertical, so let's look back and see if anything changed. Yeah. So over here we actually have only a value here initially for the vapor space. But look at, we have the sum to inlet nozzle, we have the inlet to nozzle demister, and we have the total vapor height and all of that. Alright, so this is actually what you're interested in. You want to know the diameter, you want to know the height, which is the length, and that's majorly what you need to know, and the residence time of the liquid within the tank and all of that. So let's look at something else. Now that we know the diameter to be 1.067 meters and the total length to be 3.734 meter, let's look out for the volume. Let's check the volume of the tank, or the volume will be. So come over to rating. So we already know that the diameter is what, 1.067, right? And the height is 3.734. As you can see, the volume of the tank has been calculated. Alright, so this is the orientation, vertical outline we chose earlier. So now, what's the geometry? Is it a sphere? Is it ellipsoidal head? Is it flat cylinder, hemispherical head? So you just choose if it is fair, you discover that the volume automatically changed, alright, because uh, the height was actually recalculated. If it's the ellipsoidal head, same see same thing. Sorry. Alright, so if you come back to this place, this is exactly. Oh, I'll have to type this back again because things have readjusted. So if we do this, this is what we're having. Alright, so if you want to check the nozzle, you can check all of that and check the heat loss. If you want to check the heat loss based on convection through this pipeline, oh sorry, through this storage tank, I'm sorry about that. This is what you will have. So if I click on this, so the inside vapor phase heat loss will be about 7.182 and all of that. But there's something I also wanted to check. Let's check the temperature profile. Now if we assume that the ambient temperature is 30, that is when we're going to have these values. But what if we are in a temperate region, let's say the cold region for instance, where the ambient temperature is about 0 degrees Celsius. So let's see what happens to did you notice something? Sorry. Alright, so this is what we're gonna have, which is totally different from what we have initially. Alright. If you're checking the conduction, you have the metal, this is constant, okay, the thickness of the metal is this, the density of the metal is this, conductivity of the metal, and then the solution we need to achieve overall heat loss of 0 kilocal per hour, and this is the area, okay, the area of our tank. So I think with this you should be able to size your storage tank, and that's actually the intention of this particular video. So let's do a recap. After modeling your storage tank, you go to equipment design, then click on add, select vessel sizing, then select the separator, select separator. Once you do that, from select separator you can choose any of the storage. If you have more than one storage tank in your simulation, you can choose any of them that you want to size. Then select the orientation, and when you're done with that, once you do all of that, you come to performance, you see everything. Alright, so that's just it. If you come to construction, here you can select the material type that you want. You see the mass density of the material, you see the shell thickness, you see the allowable stress of this storage tank. See the corrosion allowance, efficiency of joints, and everything. Now if you want to cost this particular storage tank, these are your coefficients for the costing. You can do that, get your cost equation here from here, or you can use the economic analysis over here. That's the capital and everything to run your economic cost based on this particular storage tank, what it's going to cost you. Okay, so basically that is that about sizing a vessel or a storage tank, as the case may be. This same process can be used to size a 2-phase separator, a 3-phase separator. During your own leisure time, try it out with 2-phase separator. Alright, thank you very much for your time.